All right, dude, we are live. What's up, guys? This is Dem Keys, and today we are going to be taking a look at. Hold on just a second. Oh, sorry. Uh, I got distracted. I'm in the middle of. Wait, what just. What happened here? That's. That's odd. Um, okay, all right. This is sort of an odd intro. Holy shit, dude. What's up, guys? This is Dem Keys. This is Damn Keys, and today we are going to be looking into three crates. We are kind of just going to be glossing over each crate. I'm not sure how much progress I'm going to make in terms of learning each of these crates, but these crates are, they do seem very useful for various purposes. So the first one is sysinfo, and actually sysinfo, there's something interesting that happened. Give me a second here. This is weird because something. Hold on, something weird. Oh, that's what happened. Okay, that's what happened. All right. Um. Okay. Yeah. So, like I was saying, we're going to be looking into sysinfo and tracing and clap. Sysinfo is for getting a bunch of system information, stuff like CPU, I'm guessing CPU usage, total memory usage, and you get information about various processes that are running. You get a bunch of other information as well, like uptime and stuff like that. Here's the interesting thing, right? When I was looking up sysinfo, and this can get really confusing. So I guess I'm words. This can get really confusing for beginners, people who have never looked into these crates before. There are two different crates. One is sysinfo, and the other is sys underscore info. That is this one. These are two different crates. These are not the same crate at all. Initially, when I was having a conversation with Gemini about this, because I have there's a small tool that I want to build for one of my more resource constrained systems. I wanna have this tool running in the background, or just in a separate shell. I want to have this tool running at all times, and every now and then, every, like, I don't know, minute or 30 seconds or something, it's just gonna check what the entire what's the total memory usage in the system, and if the memory usage, or the amount of used memory I should say, has exceeded a certain amount, then it's gonna go over the entire list of processes and find the one that's taking up the most space in memory, so the one that's consuming the most memory, and it's just going to close that. In this case, it's specifically supposed to be closing Firefox, so I know I'm going to be aiming to close Firefox in this case. This is for those rare occasions, like, actually, to be honest, they're not so rare. For the most part, things seem to be kind of fine. It's just that every now and then on this system, because the system, it's got 2 GB of DDR2 RAM. It's a very resource constrained system. I'm honestly tempted to try installing Alpine Linux on this, but I still want to do some research on Alpine Linux before kind of, just removing this entire OS, which I'm used to. Like, I'm used to this ecosystem, I'm used to the tooling and all of that stuff. Alpine Linux is great because it's really lightweight. Apparently, it's going to take, like, I don't know, um, anywhere, like, there are people who have said that it takes up 60 MB in memory, and that's crazy. So that tells me that there isn't a bunch of bloat going on in the memory. There isn't a bunch of, like, background processes and stuff like that. But I still have to do some research on this ecosystem before I decide to not switch to it, but explore it for that one specific system of mine. That being said, what I wanted to do is I wanted to build this application so that it basically crashes Firefox anytime anytime the memory usage goes so high that we only have, like, I don't know, 200 MB or 300 MB of memory remaining. Keep in mind, this is a 2 GB, like, total 2 GB memory system. So, and it's kind of weird because it I mainly watch Twitch, Netflix, and YouTube in that order, like in that order of not priority, but, well, priority, sure, but in that order of frequency. I watch Twitch a lot on this system. Give me a second. Yeah, okay. So, why was I saying all this? Yeah, it's kind of weird. Certain streams, they do just fine, right? The memory usage doesn't go too high, but certain other streams, for whatever reason, when I load them up, they're going to start consuming a lot of memory, enough that my resource constrained system is not able to handle it. If I had, like, a 4 GB system or 6 GB, 8 GB system, something, basically something that's fine according to today's standards, then that few hundred MB spike wouldn't really make too much of a dent. But on this resource constrained system, where the OS itself is already taking up a good, like, I don't know, 600 to 800 MB, I kind of have to be mindful of how much memory something is consuming. Like, certain Twitch streams, I'll open them up and they'll load just fine. Like, for example, right now I have Ariel's stream running, which I'm going to be unmuting in a bit just so I have some background sound. I'm able to watch other people like Zentrea and Vedel 987, Neurosama's stream, and a couple others as well. Filian, for example. But then there are a couple of others which I'm just not able to load them up without the memory usage spiking. Streams like Lord Athelstan, Nyanners, and Chacha, your VMom. And the crazy thing is, I used to be able to watch these people's streams on this very same system. But something on Twitch's end happened that caused the memory usage to spike up just enough that my this specific system is not able to handle it. So for these people, if I'm watching their streams, I have to watch it on one of my other systems, which fortunately I have, another system to watch it on. It's just that the main viewing system is this resource constraint system that I've set up. And for most cases, even something like Netflix and even YouTube at a higher resolution, all of these, it works perfectly fine. It's just that with Twitch, sometimes there's like a memory spike. I've had times where, for example, I don't know if I mentioned, I'm also able to watch Zentrea's stream, and I'm able to watch her stream just fine, like live. I'm not even talking about like VODs, live. I'm able to watch the stream live, and there's no memory spike. Every once in a while, maybe I might need to unload and then reload the tab again just to, like, free up memory and, you know fill it back up again, and that somehow seems to stop minor hitches from happening. But I have had situations where all of a sudden the memory just spiked, even on her stream. No, well, okay, there was one situation which I still haven't figured out what exactly it was, and my best guess would be it was one of the ads that was playing. It wasn't necessarily her stream, because Twitch has like different types of ads, right? They have those video ads, they have banner ads. So when those ads are playing, first of all, if it's a video ad, you're going to have a video playing, right? So the resolution of the video is definitely going to impact what's going on in your system. But also, you have something like the banner ad, which shrinks the video player or the stream that you're currently viewing. It shrinks that a little bit so that the banner can fit into the player. I don't know if something in the banner was really heavy and that caused a spike. Either way, um, to sort of remedy this situation, until I've had a chance to test out Alpine Linux, I'm actually tempted to load up Alpine Linux onto actually, I'm tempted to install Ventoy and then load Alpine Linux on that Ventoy USB, that Ventoy flash drive, and then test it out on actually test it out on this resource constrained system itself. I can just boot it up. Ooh, dude, hold on, wait, something just wait, no, I can't do that. I got excited for a second because I was like, hold on, just a minute. What if I was able to do like a dual boot kind of situation? But then I remembered that would only work if I had the appropriate partitioning for that, and I don't think I have the appropriate partitioning for that on this system. Um, yeah. Though, I mean, to be fair, this system, dude, I'm sitting and talking about this system. I need to explore this sysinfo crate, and yeah, just some info for anyone out there. If you are looking into writing a Rust program that gets system information, you're looking for sysinfo, not sys underscore info. Sys underscore info actually hasn't been updated in a long time. I went through and looked at. Wait, I didn't realize tracing is made by Tokyo. So tracing is another application that we're going to be looking into. At the very least, we're going to be exploring. We're going to be kind of reading the brochure of what each of these um, crates does. And hold on, where? Wait, what was that long thing that popped up? I don't know if that showed up on stream, like the tooltip showed up on stream or not. I don't think it did. Did it? I don't think it did. No. Okay. Anyways, Uh, yeah, tracing. So, I didn't realize that tracing was also made by Tokyo, which is interesting. So it might also have um, Tokyo support if that is necessary at all, because it's sort of a logging kind of framework, from what I've understood. It gives you much more sophisticated tools to create logs, something a little more sophisticated than print line. Now, I did ask, and I knew that yes, it is more sophisticated than something as simple as print line, but I kind of wanted Gemini to tell me exactly, you know, how much more sophisticated and what all it does. Um, so let me read this out. Tracing versus print line. Think of printline as a quick note you scribble on a napkin, while tracing is a professional flight recorder. Then it presented me with the table here. Actually, if I copy this table, what does it get copied as? Give me a second. Let me open up NeoVim in one of my things here and just paste this. If it's markdown, then I can probably paste it into the other system. So just give me a second here. Not sure what this is going to be pasting exactly. Oh, it pasted as CSV. Okay, it pasted as CSV. Wait, if it pasted as CSV, no, I would need a Data project to be able to. Well, I could real quick. I could just. Hold on. Okay, we can do this. Output control can be toggled. Yeah, no, that's not gonna work. Reformatting this is not gonna work. Maybe I could ask Gemini to give. Well, okay, I can read the thing. I can read the thing out. So think of print line as. Oh, you know what? I have a Gemini instance open here. I can just clear this. Actually, I don't know if maybe quit this and reopen it. What's going on here? This is sound oh, this is sound and microphone and stuff like. I still haven't placed the order for my stuff. I need to get around to doing that. Maybe today, because like I really don't want to wait until. Actually, at this point, dude, as I waited way too long, and I think I think any offers that I could have gotten, they're probably not going to be available anymore. I don't know. Maybe some offers last until, you know, mid-January or something, or the beginning of January or something. Let me see. Let me see. But I do need to place the order. I have one more day. We are currently on the 31st of December, which holy shit, dude, it's New Year's Eve. That's crazy. That's the end of this year, and I'm ready for it. Okay. I'm wondering. Actually, let's change the model first. We can use Flash. Okay. I'm no. Okay. I'm doing Rust coding. Um, can you tell me the difference between uh, the tracing crate or using the tracing crate and using just print ln? All right. While this is doing its thing, I can show you the other stuff that we're going to be looking at. So this is tracing, right? Then there's also this crate called clap. And I believe I had first seen clap in Rusty Rain when I was looking into the code for Rusty Rain. That's when I looked into clap. And yeah, I guess it stands for command line argument parser, clap. So in the past, I never actually used. I've worked on CLI tools in the past for like my own purpose, but the funny thing is, I use like very bare bones methods of parsing the various flags, the various arguments that get passed in, And it just never occurred to me that, there might be a library out there that helps you do it in a much more structured way, that's less error prone, and something that handles a bunch of the sanitization and formatting, and also catching errors in case if the user doesn't provide proper arguments. It never occurred to me, and then I started seeing libraries. Like, I believe in Python there's a library called argparse. Let me just look at that. I believe in Python that is a thing. That is how you use that is how you parse command line arguments. Give me a second. I don't even think it's a separate I don't even think it's a separate module. I could be wrong. Maybe it is. Okay, yeah, it is. It's a separate module. For some reason, I thought it's part of the standard library. Actually, no, it is. It's part of the standard library. Then why did I think earlier that it was not? I guess when I saw what looked like a PyPy link, I was like, oh, okay, maybe this is a third party thing. But no, this is part of the standard library. It says here the argparse module is the standard Python library for writing user-friendly command line interfaces. Great, awesome. The funny thing is, even on Python, I've never used um, proper argument parsing. To be fair, I didn't know. It also never occurred to me to look for something like that. It was more like, okay, in this moment, I'm trying to work on this functionality and solve this problem. So this is how I know how to do it, and so this is how I'm going to do it. And uh, this way that I knew how to do it was just yeah. This way that I knew how to do it was basically just parsing all of the so you have like a sysargs kind of list that you get from which you can read any sort of arguments that were passed the into the the script. But that's like a very raw way of reading it. I believe all you get is a string, and then you have to parse the string yourself, do stuff with the string yourself. Okay, now what was I doing? Oh yeah, we were waiting on the information which has come here, and there's a nice yeah, there's good bit of information here. So wait, let me just confirm that you guys are actually able to see this. Give me a second. Okay, yes, awesome. Where was I? Okay, so print line and the tracing crate both allow you to output information from your Rust program, but they serve different purposes and offer different levels of functionality. Print line is good for simplicity. It's the most basic way to print text to standard output, std out. It gives direct output. The output goes directly to the console. Oh, actually, with tracing, I think you might have the option to, because like with a lot of the logging libraries and the logging crates and modules and stuff, they usually also give you the ability to write to a file, like write the output to a file. It's not always limited to, just printing to the console. Where was I? Yeah, unstructured. The output is plain text, making it difficult to parse programmatically or analyze later. Then, limited context. It provides only the message you explicitly print with no inherent information about where it came from, such as a file, line, module, unless you manually add it. Okay, that is something I didn't take into account. Use cases ideal for quick debugging, simple scripts, or cases where you truly just need to display human readable text without further processing. Then trace and crate, structured logging slash instrumentation. I need to look up what instrumentation means here. Actually, in general, also what instrumentation means. Uh, right. Tracing is a powerful framework for instrumenting Rust programs to collect diagnostics. It focuses on events, log messages, and spans, which are periods of execution, creating a structured record of your program's behavior. Contextual information. Every event and span can automatically capture rich contextual data, such as source file and line number, module path, thread ID, custom key value pairs, the current span, what function or logical block of code is currently executing. Okay. Wait, wouldn't this also have a certain amount of overhead then? If all of this stuff is going on? I need to ask that question as well. Another thing I need to look into is, hold on. Um, what was I looking for? Oh, yeah. Rust tracing no STD. I'm curious if it does have no tracing's no STD support requires liballoc. These feature flags enable unstable sounds. The tracing ecosystem provides support for no STD environments, particularly through its core crates, which require disabling default features and often necessitate liballoc for dynamic memory allocation. All right. Okay. Good to know. Good to know. This will be helpful in the future. This will definitely be helpful in the future when I'm doing a bunch of robotics stuff. I'll be able to capture logs. I am curious about like how heavy this is. Okay, separation of concerns. Wait, did I miss something? Contextual, so and so, so and so. Yeah, okay. Separation of concerns. Instrumentation versus reporting. Tracing separates instrumentation, adding info, debug, span macros in your code. For reporting, it separates information which is adding info, debug, span macros in your code from reporting, which is how that data is processed and displayed. Okay. Uh, Subscribers. You attach subscribers to a tracing system. These subscribers describe these subscribers decide what to do with the collected data. Print to console, send to a file, export to external observability systems. That's crazy. Okay. Filter events based on security level, module, or custom criteria. Okay. Performance. Tracing is designed to be low overhead when no subscriber is when no subscriber is enabled. Where was I? There. The instrumentation macros have minimal impact. Filtering can be dynamic. Use cases essential for complex applications, libraries, microservices, or any system where you need robust observability, detailed debugging, performance profiling, or integration with monitoring tools. All right, dude. Okay. Um, Okay, so it seems like, wait, yeah, okay, so it seems like tracing can be incredibly helpful for um, logging various info for anything from simple to highly sophisticated sophisticated applications. But does this not add a bit of overhead? Let me specify what this is. But does all this functionality not add a bit of overhead to the system? Or is that overhead so low that it's negligible? Negligible. How do I spell that? So we have neglect, right? Negligible. Is that right? Um, Hold on. Okay. Open up a new thing here. Uh, Negligible. Let's enable spell check. That is wrong. Okay, it's there. All right. Um, Wait, where was I? Here. So low that it's negligible. Also, what is instrumenting? The only instruments, okay, there's no need to say that. I was about to say the only instruments I know are music instruments, but then, I mean, aren't like cooking utensils called cooking instruments as well? Yeah, let's not say that. Okay, so what else was it? Clap. Yes, we need to look into clap. So I have this here. I haven't opened up the clap repo. Let's open that up as well. And yeah, so I'm definitely not going to be going for the more advanced features of clap or tracing. I just want to, you know, get an idea of how to use clap, a very basic idea. Later on, I can look into more advanced stuff. It is also possible that um, there isn't any advanced stuff, as in all the functionality that's required is basically the functionality. There isn't like basic functionality and intermediate functionality and then highly advanced functionality. Maybe that's the case as well. Maybe this crate is designed in such a way that it provides you a fixed set of features and it does exactly that incredibly well. So if you're learning this crate, then you have to learn the entire thing, which might not even be all that big to begin with. So there's a derived tutorial, and then there's a builder tutorial, and then there's cookbook, and then there's CLI concepts. All right. Aspirations. Out of the box, users get a polished CLI experience, including common argument behavior, help generation, suggested fixes for users, colored output, shell completions, etc. Flexible enough to port your existing CLI interface. However, we won't necessarily streamline support for each use case. Reasonable parse performance, resilient maintainership, including willing to break compatibility rather than batching up breaking changes in large releases. Willing to resilient maintainership, including willing to break compatibility rather than, isn't that a bad thing? Willing to break compatibility rather than batching up breaking changes in a large release, which the batching up breaking changes would into like, one big massive breaking change bunch, that's also bad. But like my point is, shouldn't we kind of be aiming for the least amount of breaking changes, or preferably no breaking changes? Or maybe the idea isn't that, I feel like I keep forgetting that not all libraries are meant to be like updated all the time in your project. I mean, as in, if you have if you have added a dependency for 4 or 5 different libraries, it's not necessary that every single one of those libraries has to be updated every single time there's an update in the in the official repo, or every single time they release an updated version of the library. It's not necessary for you to immediately update the thing, because sometimes there can be breaking changes, and since your program is using the library, you could very easily break your program. Sometimes I forget that because I feel like I haven't worked on enough sophisticated projects of that scale in order to actually experience this breaking thing. I have worked on sophisticated projects, at least by my standards. They might not necessarily be very sophisticated projects. Like, I consider my VTuber app a sophisticated project, um, and I'm going to be rebuilding that sophisticated project in Rust, which is crazy. But yeah, um, I consider that to be a fairly sophisticated project. One of the reasons is because it's not just one project; it's multiple projects. There's multiple tools coming together, and there's a whole, like, there's multiple systems that I've designed for this. There's protocols that I designed for this. Not everything is fit into that one Unity project. There's like Python projects separate. There's a separate C sharp console app. There's different components to this. Anyways, reasonable parse performance, resilient maintainership. We follow semver. Okay. Oh, that's like the semantic versioning thing. Um, it basically describes a standard, or defines a standard for versioning, where you have the major version, the minor version, and then a patch version, and that entire thing, like those three things, they make up the entire version. I think there's a little more to that as well. I haven't read like those finer details. The slightly more. Wait, just a second. How long have we been? Okay, yeah. Actually, no. You know what? Hold on. I do need, because I have something on the flame right now, cooking on the flame, and I don't want that to burn, so I'm just gonna go. I mean, I did keep it on a low flame, to be fair. Yeah, yeah. You know what? I don't think I need to worry about it. Okay, so let's go back to this and read. You're asking excellent questions. These get to the heart of why tracing, or any observability framework, is designed the way it is. Tracing overhead. You're right to suspect that adding extra code introduces some overhead. However, tracing is meticulously designed to minimize this, particularly in Rust. Minimal runtime impact when idle. When no tracing subscriber is configured or enabled, the tracing macros compile down to extremely cheap operations, often just a single instruction or a few no ops. That's interesting. No, that's really interesting actually. I should look into how, though that goes into like library development, and um yeah, I feel like I have enough stuff on my plate right now. I shouldn't go into that. Okay. This means if you instrument your code but don't activate tracing, the performance impact is negligible. Compile time filtering. Tracing allows for compile time filtering based on log levels. For example, debug or trace messages can be entirely removed from the compiled binary if you build in release mode. Wait, what can be removed? For example, debug or trace messages can be entirely removed from the compiled binary if you build in release mode, further reducing any potential overhead. Oh, they just ignore the code for, I mean, I wouldn't say ignore necessarily, but they make it so the code for debug and trace don't really count in the release build. So that's not going to take up the extra overhead that it would have taken up. Then separation of concerns. The core tracing library focuses solely on collecting structured events and spans. The processing and exporting of these events are handled by separate subscribers. This allows you to choose high performance subscribers for production. Backup. The processing and exporting of these events are handled by separate subscribers. Okay. This allows you to choose high performance subscribers for production. Example, sending to an efficient distributed tracing system, and potentially more verbose ones for development. Oh, okay. It's like conditional logic, but like here you're able to apply it in a very different way. That's actually great. Okay. Sorry. Zoned out. Okay. Um, Right, batching and asynchronous processing. Many production grade tracing subscribers, like those for OpenTelemetry, will batch events and send them asynchronously to a backend, further reducing the impact on your application critical path. So while there's always some overhead, you are running more code after all. Tracing in Rust aims to make it negligible for the act of instrumentation itself, and highly configurable for the act of processing and reporting, allowing you to balance performance and observability needs effectively. What is instrumenting? In software development, instrumenting refers to the process of adding code or tools to a program to monitor its behavior, performance, and state without altering its core functionality. Wait, that's interesting. Yeah, that never occurred to me. Hold on. I could use this. Wait a minute. I could actually use this. This never somehow reading this made me think of ways that I could possibly use this library in the future. Yeah, dude. Okay, it's like adding sensors to a machine to gather data about how it's running. The goal of instrumentation is to gain visibility into what's happening, when it's happening, why it's happening, and how long it's taking. Okay, so what's happening, which code paths are executed, and timestamp of events, um, contextual data associated with events, and performance metrics of operations. When you use tracing macros like info or let span info so and so, you are instrumenting your code. You're adding points where the program will emit structured data, about its execution to the tracing system, This raw structured data is then processed by subscribers to produce logs. Wait, okay, tracing is the tracing system. Hold on. Tracing is the tracing system. Wait, am I actually okay? So technically, would print line be considered, or print line for debugging and info be considered instrumenting to a certain extent? Also, am I understanding this correctly? Is it that tracing is literally just the tracing system, or no, I shouldn't say that. No. There's a different way to say this. Is it that um, the tracing is, I should say, the core tracing system is separate? How do you, oh my God, dude, spellings, whatever. Okay, is separate from the, let's say, backends, the backends that uh, actually do something with the tracing system's output. Okay, going back to clap. Okay, then you define so and so. This is a simple program to greet a person. Great. Okay. Okay. All right. Yeah, this is great. This is actually this is another thing that I noticed. You are able to define like these. You're able to mention these attributes. This is I've seen this um in Rusty Rain's code, because I had to add one of these. I had to add the B flag, because I worked on the man, I'm kind of proud to say that I worked on the background color feature for Rusty Rain. But yeah, the B flag, which is for the background color, I had to create a separate entry for that in the struct. I don't remember if that struct was also called args, but there was a struct in which all of the flags, they would be corresponding to certain, struct fields. And I'm pretty sure that this help thing is also just like the help thing, it pulls information from all of this. Wait, where is it getting the, yeah, where is it getting this text from? A simple to use, efficient, and full featured command line argument, so and so, so and so. Where is it getting that from? Uh, okay, I can look into that later. But then we have these flags. Let's see if these flags are mentioned. So there's name, there's count, um, and I'm guessing these, the N and the C. I think this is like default behavior. This is a way to like the shorten the what do you call them? Why am I forgetting? Shorten the flag names. Let's just say. I need to look into this as well. Oh, this is specifying a short version of it and a long version. So this is specifying what the help is going to look like. Uh, so you have the short version, you have the long version, and then additionally, there's a thing for the value. So default value is this, and this doesn't have a default value. Where does it mention default value? I guess default value is oh, default value. I was about to say default value gets used when you don't specify the flag, but then no, it does get mentioned here as well. Okay, cool, cool. So then this is as simple as it is. Derive command so and so so and so. Um, oh, so this is why it's mentioning the version and about. I was wondering why these are showing up. Version and I guess help. I guess help is about. I'm not sure. And long about says none. Is this long about? And where is it pulling this information from? I wonder if this is like just default behavior, and you can then later customize this behavior. Okay, so there's a derived tutorial. Tutorial for the derived API. Okay. Available on crate feature unstable doc only. Okay. All right. Is this giving information about what's being taught here? Okay, configuring the parser. You use derived parser to start building a parser. Okay, so this is probably where I should stop because I don't currently need this. Once I need to actually customize some behavior, then I can look into this. For now, I think I can let this be. Actually, for now, let me learn the basics of this so I can actually start using it. And then in the future, as the need arises, I can look into customizing the behavior. There was another thing that I'd opened up. What is this builder? You can create an application with several arguments using usage strings. Hmm. Okay, yeah, I'm gonna need to take some time to read this as well. Oh, when should I use builder versus derive APIs? Let's take a look at that. Our default answer is to use the derive API. It's easier to read, write, and modify, easier to keep the argument declaration and reading of argument in sync, easier to reuse. Example, clap verbosity flag. Easily add a verbose flag to CLIs using clap. Wait, back up. This is a separate crate for this? And this uses... Okay, so this has implemented verbosity functionality. All right. What does that look like? What does the output look like? Um, okay, never mind. Let's continue reading this. So the Builder API is a low-level API that someone might want to use for faster compile times if you aren't already using other procedural macros and more flexibility. Example, you can look up the arguments values, their ordering with other arguments, and what set them. What set them? That's interesting. Okay. The derive API can only report values and not indices of or other data. You can interop between derive and builder APIs. Why is there a default subcommand of help? There's only a default subcommand of help when other subcommands have been defined manually. So it's opt-in-ish, being that you only get a help subcommand if you're actually using subcommands. Also, if the user defined a help subcommand themselves, the auto-generated one wouldn't be added, meaning it's only generated if the user hasn't defined one themselves. You know what? That answers my question. So we do not need. Okay, let's read the pitch. What are some reasons to use Clap? Okay, by the way, I was about to say we do not need the Builder API, at least not right now, because I'm still doing like, very basic stuff with Clap. Once I have learned the basics and I actually find a reason to use the Builder API, then I'll use the Builder API. For the time being, I'm going to stick with the Derive API and learn everything around that. And this is definitely going to help me with, the whole CLI um, argument parsing thing. Um, okay, so clap is fast and as li- clap is fast and as lightweight as possible while still giving all the features you'd expect from a modern argument parser. In fact, for the amount of type and for the amount and type of features Clap offers, it remains about as fast as get opts. If you use Clap when you just need some simple arguments parsed, you'll find it's a walk in the park. Clap also makes it possible to represent extremely complex and advanced requirements without much thought. Um, Clap aims to be intuitive, easy to use, and fully capable for a wide variety of use cases. What are some reasons to not use Clap? Okay, give me a second here. Depending on the style in which you choose to define, um, just a second. Okay, all right, cool. Where was I? What was I doing? Yes, some reasons to not use it. Depending on the style in which you choose to define the valid arguments, clap can be defined. Give me a second here. I have a bit of a memory issue going on that I need to fix, which is causing some other issues. Okay, yeah, anyways. Clap also, wait, what was I saying? Depending on the style in which you choose to define the valid arguments, Clap can be very verbose. Clap also offers so many fine tuning knobs and dials that learning everything can seem overwhelming. I strive to keep the simple cases simple, but when turning all those custom dials, when turning, whatever, when turning all those custom dials, it can get complex. True. Clap is also opinionated about parsing, even though so much can be tweaked and tuned with Clap, and I'm adding more all the time. There are still certain features which Clap implements in specific ways that may be contrary to some users' use cases. You know what? That's good enough for me. Okay. Give me a second here. I'm just checking something. Okay, we can keep that open, and we should probably close a bunch of these other things because they are eating up too much memory. All right, great, awesome. Uh, Here, I think I was. Yeah, okay. Yeah, I was supposed to be reading this thing. I forgot about that. Okay, right. So we are done with this, and I'm gonna be reading. Okay, so we don't need the builder. We don't need the builder API, definitely. We do need the derive API, so I'm gonna spend some time learning about this. And it looks like I can get started with it like relatively quick. Yeah, yeah. Yeah. I think I can get started relatively quick. Dude, something I love about the Rust ecosystem is that you actually have a tool that'll generate a bunch of this like documentation for you. Maybe not like, exactly. There's I'm sure there's a certain level of custom work that's done to create these tutorial pages, but like API documentation, there's a tool that actually generates the entire documentation for you. That's wild, dude. I mean, at least to me, that's cool because I know that tools exist out there that do this, but like in Rust, that's like already part of the ecosystem. You don't have to use like a separate tool for that, which is that's wild. Okay, going back to this thing we were looking into. Okay, you're absolutely nailing the core concepts. Um, print print line as instrumentation. Yes, you can absolutely. Um, yes, you can absolutely consider using print line for debugging and general info. A basic form of instrumentation. When you manually add when you manually add print line statements to your code, you are indeed inserting code to observe your program's behavior, state, and flow. The key differences from a dedicated library like tracing are level of sophistication. True, very true. Purpose, while it instruments your code, it doesn't provide the same level of structured data for so and so. Tracing core versus backends. You are exactly correct in your understanding here. This is one of the most powerful design decisions of the tracing ecosystem. The core tracing system, the tracing crate itself, provides the API, um, such as the info, debug, span macros, trace and span objects for instrumenting your code. It's responsible for generating and collecting structured events and spans. All right. The backends, which tracing refers to as subscribers, are entirely separate. Oh, I didn't know that. Okay, they're entirely separate crates, um, such as tracing subscriber, open telemetry, and log. These subscribers receive the raw events and spans. These subscribers words. These subscribers receive the raw events and spans from the core tracing system and decide what to do with them. Um, Print them to the console, format them as JSON, send them to a file, export them to a distributed tracing system, etc. This separation of concerns offers immense flexibility, allowing you to change how uh, how your diagnostics are processed and reported without altering the instrumentation code itself. All right. Okay. So, unfortunately, I'm gonna have to end the stream here. Okay. I kind of want to raid someone, but like, I also have to go and cook. Like, I have to prepare a salad for New Year's, and I have like a very limited time when I can do that. Um, actually, actually, yeah, no, 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 no. I need to, yeah, 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 no, for sure. Yeah, okay. I think that's gonna be it for today's stream. It's probably gonna take me some time to like find someone to raid. Um, and I also don't want to like raid and run, but then I'm gonna have to raid and run. Um, yeah, dude. I don't know. Yeah, I need to raid and run, so I kind of don't want to raid a random stream and then just leave. Um, actually, no. Should I? Because I kind of want to make it a thing to raid, not raid and run, but like to raid after every stream. Nah, I'm having trouble finding people to raid. Wait, okay, there's someone here doing music, math, coding, and chill. And their thing is verified accounts only. Never mind. Um, yeah, yeah, dude. I need to. Yeah, I'm just gonna end the stream here. Okay, that's gonna be it for today's stream. I hope you guys have a nice day, and I'll see you all next time. Peace.